Hello, welcome to another episode of the Modern Cyber Podcast. We are coming to you live from the sidelines of the Forward CloudSec 2024 conference in Arlington, Virginia. And I've got a special treat. I've got somebody who is actually live at the event with us and going to talk to us today about a really interesting topic that I don't think we've covered before on Modern Cyber. Noah McDonald, thank you so much for taking the time to join us.
Yeah, it's a pleasure. Noah McDonald, a Google Cloud security engineer over at Google Cloud. Been doing incident response for about 3-4 years now.
Awesome.
Prior to Google, I was over at Unit 42 by Palo Alto Networks.
Yep.
Yeah, it was a great time over there.
Okay, and just for clarity, for today's purposes, you're speaking as an individual, not on behalf of Google,
That is
correct?
correct, yep.
Okay, awesome. Well, regardless whether you're speaking on your own behalf or on behalf of Google, you've got a wealth of experience in this domain space, having gone through those companies that you've been with. So I want to start with just a general kind of high-level question.
Sure.
So incident response. Mm-hmm. It can mean a lot of things, I think.
Right.
Generally speaking, in a cyber scenario, it means something bad has happened, right?
That's correct, yes.
And so what are like the first couple of things that happen when an incident response kind of process kicks off?
Yeah, so when a process actually gets kicked off, it's more about understanding from the client perspective, like what actually happened in their environment.
Okay.
You know, it's understanding, is their service down itself? Like, are the company able to, basically not service its users anymore?
Okay.
Or are they basically running up a bill that they notice over time and they're just kind of questioning, like, what happened here? We have a small environment and,
okay.
Our bill is 20, 30 grand more than it should be, right?
Right. Okay. So with that said, initial assessment, what's the current state?
Exactly.
Right. So are we down? Are we racking up a huge bill?
Yep.
But I noticed you didn't say in there, have we been breached?
Yeah.
So where does that come into question?
And that comes into question. I mean, I think companies always had that underlying understanding, like, I probably have been breached at this point, right?
Okay.
They get the bill, their service is down. Usually if their service is down, they go through and speak with their engineers, like, what have we pushed into production that might have brought our application down or our companies, right?
Change analysis.
When it comes into cost perspective, it's kind of something similar, right? Like, have we deployed a database or something that is costing us a ton? And then after going through, that thinking, they pivot over to like a third party or the actual, the CSP themselves to get a better understanding of like what is actually happening in my environment and how can we understand, first what's happening, and second, how can we remediate it and get back to where, we're working as normal again.
But there's an interesting question that pops up in my mind related to that, which is kind of like going back to the CSP perspective, you've got the shared responsibility model.
Sure.
Right. And the cloud service provider is always going to say to you, well, we're responsible for the security of the cloud. You're responsible for your security in the cloud.
Absolutely. And
so to what extent can the CSP actually be helpful versus they're kind of by design not able to see everything going on in your account? Right. So what kind of questions can you ask them or what kind of assistance can you get from them?
Yeah, so there's a lot of security foundation that organizations can put into place so that Google specifically, right, can now look into, what they're actually doing in their organization.
Right.
And so at that instance, like, we have to actually ask for permission to either gain access into the environment so that we can get an understanding of what's going on.
Okay.
Or just give a general baseline of questions to get an understanding of, like, when did this start happening? Where did this start happening? How did you recognize it? What are the actual things being impacted, and then get the understanding of from there, and then diving further into the analysis itself by actually doing the hands-on work, the log analysis, the image analysis, etc.
But then, how many customers? And I mean, just kind of broadly speaking, not specific numbers. Yeah. I just wonder about a couple things on those regards. I mean, one, you're asking the customer organization to say, like, well, when did this start happening?
Yeah.
And I can imagine that a lot of the times, like, I don't know. Mm-hmm. Where did this start happening? Again, I don't know. How did this start happening? I don't know.
Yeah.
And then, by the way, like, do you have all the logs that you need to analyze this? Like, there's a lot of things that in my mind could be uncertain and unclear. I don't know. Am I thinking about this wrong?
No, it's absolutely correct. So, like, a lot of times when we start doing these scoping calls, right, getting a lot of the questions and answers from the client is a lot of them saying, we don't know, right? There's a lot of unknown when an actual company gets attacked.
Yeah.
And what comes into place is like, what do we know, right?
Okay.
It's like any nugget of information is allowing us to like use that for when we want to actually pivot into their environment and actually start taking a look around. Like, they know what is down, right?
Okay.
And most of the time, it's not the entire company that's down. There are use cases where, right, it's very unfortunate that the entire company does go down. Usually it's like some process, or they have some indicator from the actual threat actor that's doing either the ransom, or they've notified the actual organization that's got attacked. You know, something that they have, right?
Okay. But then on the lines of logging, like, is there a set of best practices or recommendations around that? Because I know, for instance, you know, for my own years working in cloud security, we provided software, not service. And in our software, we'd had a set of checks that was like, hey, you know, for instance, I'm much more familiar with the Amazon side of things. It would be like, hey, your CloudTrail is not turned on in these environments. You better do that. It's either indicative that somebody has gotten in there and turned it off, or it means that like you just never turned it on in the first place. And so when there is a breach, it's going to be really hard for you to figure that out. So like, what would you tell people about logging that they need to understand for, you know, if and when this day comes?
There's, I mean, even now, you know, working with the client side too, there's always that trade-off of cost versus the security, right? And realistically, we have to like break it down to where the crown jewel's sitting, where's like the most valuable assets sitting, and then focus around the logging, you know, around those assets first. Because those are like what is the most important for your company. Right? It's most important for not just like the application running, but also the clients that, you know, the company is dealing with. And so when we take a look at like what's most important, we try to fixate on like what logs would help us in X scenario. So for GCP instance, like if we're looking at like a GCS bucket, we're talking about data access logs, we're talking about GCS usage logs, right? And we're talking about enabling those and retaining them for X period of time. A lot of organizations that I currently work with are regulated, so they have to retain these logs for a year. And that's general practice that I give a lot of the clients, regulated or not. A year is generally what I would say is the best practice of retaining them. Now, when we talk about logs and enabling logs that are outside of the crown jewels and, you know, stuff like that, it's like VPC flow logs, right? There's a lot of them that get generated. It's very costly to store them. And
they're kind of useless.
They're kind of useless, right? But there are ways that you can still log those things, but filter out the ones that you actually want, right? So a great example of this is like data or load balancer logs, right? You don't have to record all of these 400, 404, 403, right? All of these logs are going to be useless because even if an attacker is spraying and praying, right, they're not actually hitting anything that's very, well, they might get some reconnaissance, right? But it's not actually hitting your environment to where it's going to be impacting it enough. So what we often recommend is, although enabling the logs themselves can be costly, there's ways to reduce, you know, and still gain visibility while enabling these certain logs in the environment.
So 401s and 404s, you say throw them away?
I would say it depends on, you know, the use case that we're dealing with. I would say like most of the time, like we can filter out some of these logs, especially if a cost is like a big thing that's preventing the company from actually enabling these logs in the first place.
It's interesting because I mean, one of the areas where this comes up, and like, you know, I'm a little bit single-mindedly focused on APIs because API security is kind of what we do here at Firetail. But one of the things that we see is like every API that we put online gets probe traffic within like, you know, minutes, right? And I'm saying like less than 3 to 5 minutes typically, right? And some of it is very stupid, like drive-by bots, whatever, who cares? But then some of it is a little bit more interesting in the sense that it's like, okay, got a response, maybe it was a 404, but at least that says that there is some service of some type running at this IP address. And then you see like the smarter series of 404 requests, right? Where it's like not just kind of dictionary style attacks against whatever, but it's really trying to kind of enumerate the tech stack there and discover what's running, and then you know, possibly understand a set of known vulnerabilities associated to that tech stack. So you're saying like those from an incident response perspective, not hugely valuable.
They are valuable, right? Because they are valuable, but when you're looking at the cost perspective from the client side of things, it's a way-off that they're willing to trade, right? Now, from an incident response perspective, of course, I think every log is. If it was our dream and we wanted a company, they would know every log for every service that they have, right? Even if we're talking about like Log4j, right? Like a lot of times those came in as like 400, and then they ended up being successful, right? So like a use case like that, yes, those logs are definitely valuable. But a use case where we're talking about probing or even just web crawlers in general, you're going to get so many of them that it's really just going to be more of a, hey, they're adding to the stack for a threat actor to hide their needle in.
Gotcha. You kind of answered a question that I was going to ask relative to logs as well, which is when you think about those crown jewels, let's say I've got, a workload of some type. Sure. And so I know it's in a GCP project that I've designated as my production project, right, for lack of a better term. And in there I've got, load balancer, some compute instances, and then maybe I've got a database as a service, and then I've got some object storage behind that. So you're saying, if I say to you that the crown jewels are actually what's in the database and what's in the object store, then those logs I need to turn on. It's not necessarily the case that turning on every log service for every service that I use within that GCP project is, maybe the best practice.
I would say it's more so when we talk about something like that, we need to understand the architecture that's in place, and then also the use cases of let's say the compute instance is the one that's accessing the resources, the crown jewels.
Yeah.
We need to understand at that case, is it actual people, right? Is it personas or is it a service account, right? Because there's individual ways that we can lock down each entity and each principal at that understanding. Yeah. So that we can secure those routes themselves rather than enabling logs and running up a billing cost per client. So
we could put in place things like, network ACLs. We could put in place things like, deny policies that only explicitly allow either the compute instances themselves or an IAM role associated to the compute instance that issues the calls to the backend service.
Yeah, it's really just evaluating. Well, I think one of the biggest things is evaluating the IAM and the policies that we're attaching to these things. And I think that in the cloud, you could run fast. You can run super fast, right? And that's why a lot of people move to the cloud because it scales so easily. Yeah. And then security kind of just lags behind. And one of those things that lags behind on is auditing the actual IAM around service counts, users, groups, etc. But there's a lot of things that you can put in place, like you mentioned before. ACLs, firewall, VPCSC, you can use private Google Ads. There's a whole bunch of different things that you can put in place to audit how users are interacting with your crown jewels.
Okay. So, all right, so that's all on the logging side. I guess maybe the last logging question, because then I want to get back to actually more of the day-to-day not the day-to-day, but let's say the incident response process. You mentioned something there that I think is really an important takeaway that shouldn't be just left alone as kind of a side comment, which is that okay, so we've set in place this architecture. We've kind of analyzed, what is the access route for, compute service to crown jewels data in whatever store format they are. But then actually also logging the IAM credentials around who/what has access to modify that is actually really critical, so that if we do find later on that it was access that came in through our own compute instances to these services, but it was unauthorized access because the IAM role was compromised, well, we need to understand where was that role compromised.
Yeah, absolutely. Yeah, I think there's a lot of safety protocols that you could put around auditing the access around the IAM, the service count, the user, right? Yeah. Auditing those allows you to, as an analyst, pivot off of and kind of track down the initial attack vector. Yeah. Or, the initial how did they get access? Where did they get access, etc. Yeah. And oftentimes it's sorry, can you
go ahead.
Again?
Yeah. So if we find that the breach vector came in through the compute service, through an IAM role that got compromised or got utilized for that purpose, then we need to have audit around the IAM to understand how that was compromised in the first place.
Yeah, audit around the IAM, and then also just looking at the infrastructure around the compute instance. What is specifically there? How is the users able to access the service account in the first place? Is it through an application? Is it through an exposed compute instance in the first place, right?
Or was it, let's say, through a developer's IAM credentials off of their endpoint or something?
It can most certainly be that. Yeah, I've dealt with that before, right? Yeah. And it's also not always external users. It's also sometimes internal users, right? Yep. And that's something that we have to be aware of as well.
Yeah. Interesting. So let's get back to kind of the process, right? Sure. So we've talked about logs. We've talked about kind of, the importance of having logs, because when that day, hopefully for your organization, all of you out there listening, hopefully for you, it doesn't come. But if and when it does, you need that. And then what actually, kicks off? So we've talked about how we're going to check the availability of the services. We're going to assess our current state. We might reach out to the CSPs for more information, try to understand what they're seeing from their side as far as, I don't know, what new services we've deployed or what bills we're racking up here at the same time. And then what, from an incident responder's perspective, happens next?
Yeah, what happens next is, and it's weird that you're like, let's pivot off of logs, but I think incident response is really a lot about log analysis.
Okay.
And sure, there's also traditional forensics when it comes into like looking at compute instances and databases, etc. But in the cloud, like one of the biggest things about the cloud is you have so many logs you're able to gain visibility into through compute instances, through the different services in the cloud itself.
Yeah.
That at the end of the day, a lot of the analysis itself in the cloud is log analysis.
Okay.
And so what really kicks off is, okay, we already asked our client all the questions that we need to know. We got the initial scoping done. We have a general understanding of like what the issue is. Why did the client originally contact us?
Yep.
From there, what we actually do is we grab all the logs in their cloud environment, if they have them, right?
Yep. And
we start performing frequency analysis against these logs. We start understanding, what is unique in these logs. And that's like looking at user agents, IPs, the method names themselves, right?
Okay.
And then kind of just building a timeline out from there. So like most of the time, we don't know when the initial access is, right?
Yep.
We always work our way backwards. We always need to understand, okay, we have this user account or service account that we see doing malicious activity.
Like now.
Right.
So at the point that you start the response, so you look at like what's going on right now and then work backward from there?
Exactly.
Okay. Sorry, I didn't mean to interrupt you.
Yeah, absolutely. I mean, that's the most obvious, right? Like, it has been impacted, right? Let's say your server goes down.
Yep.
When you start looking at those logs, you start seeing who or what has been interacting with that server itself. You start looking at the actual API calls that it's been making, and you're able to be like, okay, is this anomalous or not? And you do like a back and forth between the client. You like get an understanding because, this is, as an incident responder, your first time in the environment. You're not sure how things work, right?
Yeah.
So there's a lot of back and forth and getting an understanding of like what should this service account be doing? Who is this person and what is their activity in the organization? And once you start identifying anomalous activity, you're able to be like, okay, we know it's from this service account, this user, this IP address. What other anomalous activity have we been seeing from this user, from this IP address? Because oftentimes it's not just a single identity that the actors are using or a single IP or user agent, right? And so that's where we start to build our profile against like, okay, they've not only moved from user A to user B, or they've took a time, like a break of like performing a reconnaissance to actually deploying the attack themselves.
Yep.
And once we grab all the analysis from there, we start looking at the actual assets that they've touched.
Okay.
So we're like, okay, we have a default service account that is normally attached to this compute instance over here, performing anomalous activity against this database or GCS bucket, right?
Yep.
And from there, what we do is we'll be like, okay, we know that this service account or user is often interacting with this compute instance. Let's take a look at that compute instance. Let's take a look at that container, right? And let's image this, and we'll do a light forensics first. What we'll do is we'll grab the most important logs from that actual instance itself, perform a quick triage of this, and if we identify that there's a malicious startup script or there's something that's actually embedded into the compute instance themselves, we'll take a full image of it, and we'll perform, basically, at that point, it's traditional forensic analysis against the image itself.
Yeah.
And that allows us to start getting an understanding of like, okay, this may be one of the initial attack vectors. This is probably how the threat actor got in. And then from there, like we start getting a general understanding of like, okay, did they come from another inside method? Did they come through this load balancer? Because load balancer provides a lot of valuable information as well.
Yeah.
It's usually sitting in front of applications or assets, right? And really, we just start to build out our timeline from that point on, and we just are able to like, okay, we're starting to communicate with the client, like, this is what we're seeing, these are the services, this is how they got in, this is the exploit that they used during the attack here. We start running through with the client, like, there's two different pathways here. It's like, if the threat actor is still alive in the environment, we often try to isolate the threat actor, and we try to not tip them off that we know that they're in the environment. That's the lesser use case, but it's happened before. The other use case is the threat actor has gone in, done their thing, and they've are either ransoming the client or their service is down, right? And from there, we start actually working on remediation with the client, like saying, like, all right, let's repeat these credentials. Let's remove this user completely. Let's try to stand back the infrastructure if we can, right? We want to not rebuild if possible.
Well, I was going to ask that question because, I'm dating myself a little bit here, and I think it's fair to say I might have been in the tech space a little bit longer than you, but going back to the days when I was hands-on keyboard, one of the things that we took for given at that time was it was far cheaper to re-image something than to actually try to, let's say, remove every last remnant of, in these days, I mean, we're mostly dealing with viruses and kind of early malware, right? Nobody wanted to go back and try to figure out like, oh, well, what are the extraneous registry keys that have been planted on this system that nobody knows about and shouldn't be there? Like, nobody wanted to go through that process. So for us, it was far cheaper to just re-image the box. But it sounds like you're saying that's not the best practice on cloud environments.
Well, I would say it's not always best, right? Because oftentimes rebuilding it takes a lot of time and it's pretty costly. And from that point, like, we need to understand, okay, like, we need to weigh our pros and cons.
Okay.
And this also comes from like the understanding of like the analysis itself. Like, if we know the true attack vector of like how this threat actor initially got in, then great. We can remediate that actual artifact itself or remediate that compute instance itself, and we don't have to rebuild. But a lot of times, it's hard to find the initial attack vector of how they came in. So sometimes we have to do the rebuilding process from there. And like I said earlier, like, in the cloud, you can run fast and quick. Like, you can put up things really fast. And so what we do from there is we actually advise the client to build almost a golden image. We evaluate that golden image, and then we have them redeploy it back into their infrastructure so that they can get back up and running.
I mean, it's funny because, like, again, my default inclination would have been, you know what, new project, new IAM roles, new, let's maybe even bake the image for the compute instance again. Let's rerun our IAC. Let's double check our IAC before we run it again. That totally would have been my default set of assumptions.
There's a lot of, it also depends like what asset you're looking at, right? Like, oftentimes if you're looking at a server that's the main thing that's running your application, it's going to take a lot of time because a lot of time has already gone into building this, right? Sure, they might have backups of this, but then the threat actor will just get back in, right? Because the vulnerability is still present at that pace. So oftentimes we look at it and be like, okay, if this server is really important to like this pipeline or this application, right? Let's assess like the vulnerability that's actually happened here, and let's just try to remediate this instead of rebuilding the entire thing. And also, the other point is, if you're rebuilding, it also adds to the time that the company is down. Right? Which time is money at that point.
Well, let's talk about timelines, because there's something that's been like kind of in the back of my head as we've been having this conversation. First of all, I think, this has been super educational for me. I think there's a lot more that goes into incident response than people think. I think a lot of people think it's like, oh, okay, I've got a run book, execute, right? Or, I'm just going to like take an image of things, hand it off to somebody, and we try to continue life as normal, which may sort of be the case if you're working with an outside firm. Like, I don't know. But what it brings to my mind is a couple of questions that, like, number one is actually like gathering the logs and then putting them into whatever system you're going to use for your analysis. That's going to take time.
It does take time. When prior experience when I'm working at like a true incident response firm, there's a lot of automation and in-house tools that we build to automatically sync those tools over to either our cloud environment or to our SIM. So that way we're starting to be able to perform the analysis while a user's in the client environment and poking around with what's going on in there.
Okay, but these log files, A, they can be big.
They could be big, yes.
And B, then the analysis, let's say the queries that you're going to run across them, like, you mentioned this kind of frequency analysis, and I know there's any number of flavors of different anomaly detection type of algorithms you might apply to them. Getting them, loading them, then deploying these algorithms on that data, that takes time as well.
It does take time, and a lot of companies don't have, from experience, like terabytes of data that's just sitting there as logs that are like tracking for forensic purposes. So at most, what I've seen in like actual cloud incident response is maybe a terabyte of logs. And realistically, we can get that over in like an hour or two. So we are losing a little bit of time. However, for the companies that do have a larger amount of like forensic logs or just logs in general, what we'll do is we'll start looking at the logs as they're coming in and start looking, seeing what we can find. In addition, we also pick out like the time frame that we know the impact has happened, and we grab those logs first. And once we know the threat actor came, before that timeline, then we'll start to pull logs, further back. We don't pull all logs in the environment because it would just waste time, right? We look at the timeline. We usually do a week before and a week after the actual incident had occurred. And then from there, we start building our timeline. Okay, if it's still a week before that week, let's pull back another week of logs, right?
Okay. And then what about the cases where, for instance, data shows up on a darknet forum and you don't really know? Like, obviously the customer has been breached, but they don't know the timeline when they were breached.
Yeah.
So how do you start that process?
Yeah, that process, when you work at an actual incident response firm like Unit 42 or Mandiant or likewise, right? Oftentimes you'll have the threat intel that is identifying the actual data that's on the dark net, and that's working with the incident responders to be like, hey, this is what we found from the client perspective.
Yep.
And often that's like a sore subject, bringing it up to the client, whether they know or not, right? If they don't know, which oftentimes they don't, is us like really sitting down. We have to be transparent with the client.
Yeah.
First, it's our job, and second, it's due diligence, right?
Yeah.
Because not only for like cyber insurance reasons, but also for their users themselves. Like we need to get ahead of these things so that the company is like aware and can start building a process of like how they're going to publicly like talk about this.
Yeah. And I mean, there may be things like, let's say, like identity protection, and there may be financial implications.
Exactly.
And so on. Okay. And so part of the reason this whole question of the timeline comes into mind is that these new guidelines from the SEC about reporting periods, and I think it's 96 hours, right? It's like 4 days.
Right.
It seems to me that that's like a super high pressure,
it is,
relatively short time frame.
Yeah, it is. When you work with the incident response, the incident responders, at least from my experience, they know that, right? And so they're working hours on end to kind of uncover like what is happening. That way we can give the client information rapidly.
Yeah.
Most times we'll have like a live bridge between the client and the incident response firm themselves. Most of the time the analysts aren't a part of that. It's more of like the manager level, right? Or the C-suite or executives at that point. And then the analysts will start feeding the
data.
The data and then like information as we're finding it, right?
Okay.
But oftentimes we need to be sure, and we work with like our threat intelligence community, and we work with our malware analysis to make sure that we have all the facts about like what we're doing before we present it to the actual client themselves.
Got it. I mean, this is super fascinating. I mean, we could probably keep talking about it for hours, but in the couple minutes that we got left, I guess if I had to kind of take away a few high-level themes that have come out of this, number one is, even before you just say, hey, turn on logs, you actually need to understand where the crown jewels are and like what the key things that you really need to be worried about logging around, right? And then number two, if I hear you right, is you need to think about like how are those crown jewel data kind of accessed.
Absolutely.
And then really it's like those critical paths around that, and then an abstract layer of audit on top of kind of the IAM and everything that kind of can access and make changes to those paths.
Exactly, yeah. Oftentimes what I tell customers is like before we implement architecture, or as we're creating these major changes to our infrastructure, what we need to do is actually blueprint out our architecture and start running through the use cases, the personas, the requirements for this infrastructure, identifying what assets live where, how they're going to be accessed, and then doing a threat model against this. Not only looking at external actors, but also internal actors.
Right.
I mean, the three biggest things about how people get infiltrated in the cloud is misconfiguration. That's one. The other one is actually doing the OWASP top 10. Whether it's like a 0 day or something wrong with the application. And the last thing is credential exposure, right? Which I guess you can kind of bleed into misconfiguration, but you're right. People are doing GitHub repos that are doing GitLab, and they're just submitting things because they want to get the infrastructure up fast, right?
Yeah, I mean, the number of times you see an access key and secret pair in a committed code repo is pretty staggering.
Exactly. Yeah. So really just the whole threat model, and then building security recommendations or requirements around that to match with what you've identified as an attack vector through external or internal actors. Got it.
Okay. And then when, if and when that day comes, let's say you've gone through that and so you're relatively prepared.
Sure.
When you engage an incident response firm as a customer, as an organization that's going through an incident, what's best practices for that customer organization to know when they first reach out to a firm like a Mandiant or whatever?
Yeah, I think the thing is, things like you've already been breached, right? I get that, stuff's on fire right now. You're getting a lot of pressure from, management. It's going to happen. I understand that. but you have to allow a time for the analysts to go through and analyze like with what is happening. So I think time is one.
Okay.
It's okay. Like,
yep.
It's not okay, but it is okay, right?
Okay.
It's happened, right? Unless the threat actor is live in the environment, we can worry a little bit more. Right?
Okay.
The other thing is we need as much information as possible, whether it's relevant or not to what we're doing. The more information that we understand about the environment, how it's accessed, what has happened in your environment that you know of, will allow us to pivot on your logs a lot faster, right? If we know that, the reason you're contacting us is because you got a guard duty or an SEC alert, and this is like the first sign of an infiltration or an attack, let us know, because the fastest thing is for us to go into guard duty or SEC, start pulling out the alerts and related things that are associated with that. As we're grabbing the logs, as we're doing the imaging
so you
process.
can correlate, you can look for time frames.
Exactly. And it's a response. It really is just like doing it as fast as possible so that way we know what is going on and how can we remediate as fast as possible. So the more that we know, the more that we can assist you in the fashion we can assist you.
Okay. So customers need to be open, basically.
Yeah.
All right. Well, Noah McDonald, this has been really an eye-opening and very interesting episode. I learned a lot of things, and I had a lot of assumptions about incident response that turned out to be wrong, and I'm sure a lot of our listeners will have had the same experience. So thank you so much for taking the time to share your expertise with us today.
Yeah, I appreciate it. Thank you for having me.
Awesome. Well, we will talk to you next time on the next episode of Modern Cyber. In the meantime, sharing is caring, so please do, share this with a coworker, rate, review, subscribe, all that stuff. You know what we're going to say, and we'll talk to you next time on Modern Cyber.